All right. Interesting fact. Our modern digitally enabled world needs a continuous source of power to function. Pretty sure you've noticed we've all got batteries, everything's plugged in, right? All it takes is a momentary blip in that electrical energy to our device for it to shut off. It's about 0.02 seconds or 20 milliseconds. So when you look at that, keep that in mind to kind of get into this concept of AC and DC voltage. So the overwhelming majority of our modern world runs on DC power. So you look at your lights, your computers, your different, like this is an access point, your networking gear, your car, all of these things are native DC voltage devices. The challenge though is why are we still using AC power? Well, it's because at the time it made sense. When it first came around, AC was the better way to move that energy long distances. And so that's very well established, it's well understood, and that's where most of the National Electrical Code has been focused on for quite some time, is the AC voltage. It wasn't until the very recent code revision cycle, specifically the 2023 NEC code update, where we started getting better guidance on DC voltage anyway. The cost has been a lower cost solution to be AC for quite a while, and most of the big legacy players are all predominantly around the AC voltage side of the industry. So when we look at that, got a couple of challenges. So first challenge, batteries operate as DC voltage and require expensive electronics to actually produce that AC voltage because they're DC devices, they need AC components to change it. I've got one from behind me there that's a UPS power block or inverter. If you look at this example here, this is the Powerwall 3. You can get that for residential or commercial use. With that, you've got a big battery and then you have inverters inside. The inverters are the expensive part. When you look at that on my side as well, in a commercial building, these two things are the same exact device. Both of these come from my projects in my prior role. The white one is a UPS that's supporting their IT loads. The red one is a lighting inverter, also a UPS, that is supporting the emergency loads. And the code required two separate things. They're both batteries, and if this equipment had been able to provide power directly to the lights as DC voltage, you wouldn't need these big power blocks, these big inverters in place. Also, the code update is going to allow us to blend these two together and use software to control them. We're not there yet in Utah, but we're very close. Next challenge, voltage conversions are inefficient and wasteful. So if you think about this as I've got $100 at the side of my building when that comes in. If I have solar and batteries in that building, by the time that energy gets to my light, I've only got $80 left. However, if I just take that as DC voltage energy, so I have a battery, I have a PV array, right? If I just took that as DC voltage, I'd have $95 left over when I got to my light because I don't have conversion losses. So one of our partnerships is with a company called Loom IO. I actually have one of their switches right here. And this switch allows them to take DC power in, DC voltage, 48 volt DC, and on the outside, we can then power all of our lights directly with this. This is a lighting driver. So what that allows us to do, instead of having all these conversion losses, you go from DC to AC to AC to DC to DC to AC, back and forth, right? Every time that changes, you lose about 5%. So as you come through there, we want to reduce those conversion losses. The other side of it is AC voltage equipment typically fails much earlier than DC. This is not our marketing claim. This is the national labs. They've done quite a few studies on it. And if you actually look at mean time to failure reports for equipment that can take both, so some IT equipment has a power supply that will take both of them, and you look at, say, Cisco's mean time to failure reports, and you have the AC voltage one, X number of hundreds of thousands of hours, and you have the DC one. The DC one is almost always about 2.5 times as long. So when you look at things that need regular maintenance, nuisances for me in my house is my lights, my down lights. I have LED, we put them in 9 years ago, but they're 24 feet up into the ceiling? So they're starting to fail, and what's failing is not the LED light bulb. It's the AC components, the AC voltage components in the base of the light bulb. That's what fails. So if you look at this from a commercial side, this is the same issue. I'm sure you've seen these things before. You have a marketing claim, 50,000 hours of life, 22 years. These never make it. The LED can indeed have 50,000 hours of life, but this driver is what fails, the AC to DC voltage driver. And all LED lights have to have this. Even when we bring it back to the DC side, you still have to have it. The key here is, where is that driver? It's up in the ceiling, right? It's in the light fixture. So now as you're maintaining that equipment, not only is your light fixture failing earlier than it could, but you have to get up into that ceiling, pull out that driver, replace it. It's a nuisance. When you do this with DC systems, we can centralize that driver. So not only will it last longer because it's straight DC voltage, also the maintenance component is much more readily accessible. Think like a circuit breaker. So instead of having the driver up in the ceiling, we have it in a panel, just like a circuit breaker panel. And when that driver does need to be replaced, pull it out, put it back in, and it continues to function. So that's a benefit of that. So this is what the LED lights look like. And you can take practically any light out there, and we can have that converted with very little effort to feed it DC voltage. In this example with these lights from Home Depot, the halo lights, quite literally, we can just detach that and plug it in the DC voltage. No other changes needed. So you can even pick the same lighting in most cases. So where we started off with in this last year is we started off with a SAS-based component where we were thinking, hey, let's do a controller. And so we have this novel controller, allows us to speak battery. That's a language called CAN bus. I'll get into a different video on that. But we developed it. It's like, that's cool. But then ultimately, who wants to be the first one to do it, right? So what we did is we paused our development efforts. We've only got a beta. It's not all the way ready for production. We said, all right, rather than doing this first, let's just pick off the easy stuff that's already on the market, establish a reputation in the industry, and enable developers and building operators to use some of these other services. So what we're finding is there are all these products out there in the industry. They're UL listed. Some have been available for the last decade. But because DC voltage is unfamiliar, we have this challenge where each of these different stakeholders in the industry, they're just not sure what to do. And so what that leads to slow adoption and inaction. Our objective as a contractor is to just do it, to take those devices and implement them. And our controls will come along the way. We really are excited about this. They will get there, but this needs time, and let's call it some cash flow and revenue to support that objective. So, our premise is that on-site energy creation and storage are the key factors. But the challenge is we want to have that DC voltage, and that's unfamiliar, and then the batteries then are expensive, more specifically the AC voltage components of that battery. So the premise is like, all right, cool, that's fine. I need to have constant power, right? I need to have that always on. I'm just going to take my Tesla PowerShare with my new Cybertruck, and I'm going to plug it into my house. Like, all right, that's cool. That's cool. We got that here. We're certified. We can definitely do that. Put a Powerwall in if you'd like as well. Takes about a day. Go in, update the service. Not horrible, right? We're doing it with the big electrical wires in the house, but not so fast. Because guess what? You need an always-on solution. Remember that blip, that just moment's blink of the eye, loss of electrical? So what happens is when you have energy storage, Tesla, any commercial battery energy storage system, unless it is an uninterruptible power supply, meaning UPS, you will have a blip of power when the utility goes offline. So when Rocky Mountain Power shuts down, you've got your Powerball or you've got your Cybertruck. It takes about a half a second to upwards of 2 seconds for that for the controls to disconnect your facility, whether it's a building, a commercial building, or a home. It takes about half a second to 2 seconds to disconnect from the grid and then allow that energy to start producing power again for that building. In that moment, your lights went down, all of your computers reset, your networking all reset, if you didn't have an uninterruptible power supply. So residentially, we may not have those, or not as common, but on the commercial side, you typically have these, and they can be very, very expensive. Those were the photos from earlier. So we found that everybody kind of needs the same thing. And all of these challenges are easy to support if you just toss the money at it, right? Go buy a few $100,000 of UPS, put it in your building. Go buy wall packs for your egress lighting, right? Go buy that UPS. But we found that we want to solve for the least common denominator, the low cost system. So we found that Guys in Africa, they're already dealing with DC voltage sides of things. And if you look at batteries or like, we have options that provide resilient power. Same thing with the MDUs. All of these things speak DC voltage, and we just need a basic battery. We don't need an uninterruptible power supply for the simple things. So if you look at your lighting, you look at your IT loads for a residential property or say a light commercial property, what we can do is we can evaluate what's needed for that facility. So as an example, with this Loom switch, this example would be for, say, a tilt-up warehouse, right? So you have a whole bunch of high bay light fixtures, maybe your 10 years, your 10-year refresh cycle. What we can do is instead of feeding, say, 277 volt out to all those lights, we can feed it with DC voltage power off this switch. And with that, we can also provide power straight off a 48 volt DC battery plant. So instead of needing an expensive inverter or an expensive UPS, you just need the battery and a very basic charge controller. Or if you don't even want to do that, we can just feed it AC power like normal. Let's put a power supply in place, right? So the type of project to start is we want to use products like this to enable customers to test the waters, to try out lower risk projects that don't have some new controller from some new startup company. If you don't have batteries, that's fine. We'll just use one of these other options, right? Or if you have other solutions, we can put together a package that allows you to use as much DC voltage energy within that facility as possible. The objective is longer lifespan and lower maintenance headaches over the life of that product, as well as lower installation costs. So in practice, what happens is it's about a push to maybe a little bit of a premium to do this on the front end. So if you do traditional means and methods, and then you do this DC voltage, we often have to pay a little bit more for the DC. We're talking 5-10% perhaps, but you get the benefit. There's a lot more controls there, and there's a lot more things you can do with it. It's also more energy efficient. And you can then capitalize on the available green energy tax incentives, as well as deal with, if you want to have, say, a LEED accredited facility, this gives you bonus points within LEED just to go DC systems. Same thing with the other commercial buildings. We can send DC voltage power over significant distances. I'll get into this a little bit more later on. This is what's called Class 4 power, and we are a partner with Volt Server to implement their solutions. On the residential side, it's much more simplistic, where and this is why we're focused on this part of our conversation yesterday, is within a residential house, even in our house, we're about a 4,200 square foot home in Draper, I can take our lights and have every single light on in the entire house, and we might be pulling 1,500 watts, maybe 2,000 with all of our Christmas lights on right now, right? My IT stack, I've got a pretty advanced stack of switches and routers. That entire stack is a few hundred watts. All of that equipment could be DC voltage. The challenge is, as a retrofit, it really doesn't make sense to pull apart the whole house. You really need to be new construction or a significant TI refresh for a commercial property. So what we look at is these residential properties. We can provide the green energy assets. That could be a wall connector or a charger for an EV. That could be providing a Tesla Powerwall for the premium communities that want it. But foundationally, we can implement a solution that has a very basic 48 volt battery. And with that, we can distribute power to all of the lights and the fans in that house. And off that 48 volt power, we can also provide power to the cable modem or the Google Fiber modem and your access, your router and your access point. So when you have that utility interruption, even if you don't have a Powerwall or a Cybertruck, what you'll be able to do is all the lights will stay on, your cameras will stay on, your smart property technology will stay on, and that one battery for a house our size, that one 48 volt battery would allow our house to run for about 2, maybe 3 hours. That battery is only like $1,200. Needs a $1,200 and a little charge controller, right? All you have to do is make the choice when you're implementing that solution. Now, granted, there are other things that come into that with control systems back and forth that you can kind of layer onto it. But foundationally, if we just did nothing but change how we powered the lights in that house and how we powered our security and our IT, we can keep all of that on for very, very low cost. And then if you happen to want to upgrade to a Powerwall or something where the entire building can have backup, well, great. Now what do you have? You have the ability to keep your core infrastructure online. As an example, the house that our team did just yesterday, they did a power share installation for a new client. In that example, we had to turn off the power to their house a couple of times. And when we did that, the entire house turned off. If they had had 48-volt lights and this battery, they could have kept all of their creature comforts on, including their Wi-Fi in their internet access. They had Google Fiber, and they could have had all that Wi-Fi on. No, you don't have the TVs on. No, that the AC is not going and the heater's not going. But the house is functionally habitable. And you also have the comfort of, if you were away and you had a utility outage, what do you want to know? Like, hey, the power's out. What's going on? What's happened? Even if you have a power wall, all of your systems have just reset if you don't have an uninterruptible power supply. Remember the expensive part, right? So if we can keep all the lights on and the security for low cost, then all the premium stuff that you bolt onto it that comes along with it, it functions better because you don't have that blip. So that's where we're focused on this residential side, is the projects come up a lot faster. It's a much quicker turn, but make no mistake, we want to do the same things on the commercial side. And right now, we just need the simple jobs. If that means we're just doing Tesla wall connectors every single day, so be it. We'll do that because I need to keep my technicians busy so we can do the rest of our R&D on our controls, because we can make all of this better as a hybrid system. So as the last little tickler on the commercial side, and then I'll drop off this video, is we believe in a hybrid system. Just like you could go have a Tesla EV, right? An expensive premium automobile. I would wager that the vast majority of people in the West would benefit from a hybrid vehicle, a plug-in hybrid like the Prius Prime as an example. Same thing with the building. Yes, technically we could make the entire building DC voltage. Same thing for the home. My personal feedback is we shouldn't. Until that equipment has the ability to be maintained readily, the service ability of that equipment is more available right now. It's not that you can't go buy all these devices or refrigerators and the like as DC. It's that once you install them, if the service community is not ready to service and support that, I think we're going to ask for some maintenance challenges. So our premise is focus on the low-hanging, easier fruit. Lighting and anything that's IT or security enabled. Almost all of those systems are native DC voltage, and we can bite them off, support those, bolt on some EV charging as part of that, and then based on those systems, as time elapses, 6 months, a year, several years, we'll start bringing other devices or HVAC and things into the system. Appreciate that. That's a little bit longer on this one, but we'll step into the next topic here with the Tesla Cybertruck Power Share as well. Thanks.